Welcome back all, this is Daz from Motorola Techniques. Up this week I'm looking at doing some infrared controlled crossing gates like shown on the video here. So it's just a little bit of animation that I've added to my layout. So I'm going to step you through the hardware side of things, the software side of things, and everything in between. So just rest assured that the infrared on those crossing gates are not where ultimately it's going to be. So you'll see this backing up and it'll get halfway through the crossing and then the light will go off. The reason I've just done that purely for the video, so we didn't have long stretches between the infrared. So just thought I'd point that out because I'm sure I'll get some comments below regarding it. So big shout out to my Patreons out there. Every little bit counts. Link below if you want to help me out. So without further ado, let's get started. MRT Scale Prints, helping you to add realism to your model railway. We are producing craftsman quality prints in various scales, including HO, O and N scales. We are proudly Australian owned and operated. www.modelrailroadtechniques.com. So let's get started with this little project. So let's quickly go through the parts and components that you're going to need. So you're going to need an Arduino Nano, a micro USB card. Doesn't really matter on the size because it's the sound file is only a very small file. Obviously a USB dongle to get the sound off your computer onto the sound chip. You'll need an MP3 converter. I'll put full links to the description below all these parts. You're going to need 2 IR detectors for the Arduino. For research and development, you're going to need a breadboard. You'll need a speaker and some jumper wires. So let's crack on. I'll put this circuit together and we'll give it some test. So the first thing we're going to look at is putting the sound onto the memory card. So I've put the micro SD card into the USB reader. So as I said, it doesn't really matter the size of it. Probably 1 gigabyte will be more than enough. So the first thing you're going to make sure you do is needs to be totally formatted. So just make sure there's nothing on there like the wedding photos or the photos of the first child, grandchild, or whatever. Obviously that's not going to go down real well. So it's got to be totally formatted for the file to be read by the Arduino. So that's just a very simple, I'm in my Explorer here, so it's very simple. It's just a matter of going up to format. It'll ask you to, I'll just do a quick format and it'll do its thing, and that's done. So the next thing we need to do is, after formatting, we need to create at the root level of the folder. So we're at the root level right now. A folder that says MP3. So it's just a matter of new folder. Type that in, MP3, all lowercase, and then with that, it's just a matter of, if you've got a file ready to go, you just drag and drop your sound file into that folder. So the folder has to, the file has to have the file name of 0001. So the reason why that is the case, when the Arduino looks for the sound file, when the IRs have been activated, it looks for the first track. So basically the way it'll work is, if you have another track, it will then, after that one's finished, it'll keep playing. It'll go number 2, 3, and 4. So just, obviously we're only going to have one track in here, so 0001, and then we can get out of that. Now this is not a video on the sounds of the bell, how fast they are, what they sound like. That's obviously going to be different compared to your part of the world that you're in. So I'll leave that up to you to source your own file, but it doesn't matter how long the file is. This one's only best start of 12,000 kilobytes, so it's not a very big file. And then after that, it's just a matter of going through, make sure you eject your micro SD correctly. All right, so what we've got here is, now we've opened up Arduino IDE. I'm not going to go through how to download or anything like that. There's plenty of other really good videos out there, so it's just a matter of searching them up. So this is the sketch, or the program, so to speak, that's been written by Dr. Geoff BUNZA. So a big shout out to him, and thank you very much for writing this particular one for me. So I'm not an expert in Arduino, but I will step you through just a few little key points. There's nothing you need to change on this. However, just to be mindful if you do have a few issues regarding the hookup and all that, what you need to do. So I will go through quickly how to what they call flash the Arduino. So once your Arduino's in, you need to go up to your tools just to make sure you've selected the right board. So what I mean by the board is the little Arduino chip is the board. So this is a little Nano. You can put this on an Uno as well, but I've selected the Nano. So the processor type, 328p is what I use. Now the port can be a little bit of a funny one sometimes. So mine's on port 11. Now if you don't know how to go in and find out what port that you're on, what you can do is, this is the Windows 10 machine. So it's just a matter of going up. I do it this way. There's probably easier ways. Device Manager, and you'll see your COM ports. So there's communication ports. And I know mine's sitting on 11 because I know this is a USB serial channel 340. So if I just unplug that, you look what happens. So once you unplug it, you see what happens. We drop a COM port off. Obviously, I've got other things plugged in here, so I'll plug it back in, and you'll see the COM port reconfigure itself into 11. So it's just a matter of communicating that across with the Arduino IDE interface to select number 11. Then from there, it's pretty well simple. You got the buttons up the top here. You can either compile it or upload it. So we're just going to upload it because what it does, it will compile it first and then go through and upload it. So you can see down the bottom here, bottom left-hand corner, it says done uploading. It's as quick as that. So we'll just quickly go through on the software, if you were to download it, how you get the connections, because Jeffrey has shown me all the connections, all in the sketch. So he starts them across the top here. So we start with the little MP3 player, and I'll step through those in detail further in the video. And then our sensors are here on pins 5 and 6, digital pins 5 and 6, and the LEDs on 10 through to 13. Now, as I said, there's nothing more that you need to do with this sketch, but there's obviously a few things to be mindful of. So, so basically the way it works is we got the sensors on 5 and 6. So that's the root of how this sketch works, or how this system works. So basically what it's saying, it's trying to work out is if sensor number 5 is triggered first, obviously then 6 goes into like a standby mode and then sets all the lights off, or the LEDs with what they call pin modes, and their outputs on all your LEDs. So then you can sort of see that the digital write function here is they go low after the next sensor is fired off, or sensed, I should say. It'll pull the LEDs low, so that'll effectively turn them off. So this line of sketch here also ensures that when you turn the system on, the LEDs are off until the sensors are fired off. As I said, nothing else you need to know here. I'm no expert in the field of Arduino or writing this code. It's well beyond my capability at this point in time. So a few other things you do need to be mindful of. There's a few what they call libraries within Arduino that you need to look at doing. So some of them obviously already here, the software serial. Now, but the big one here that you're going to need is this one here, which is the DF Robot DF Player Mini. So if you don't know how to download libraries, it's as simple as going Tools, Manage Libraries. So how do you add the library to this sketch? So it's just a matter of going Tools, Manage Libraries, and I'll bring up the interface very quickly. It's been a bit laggy today for some reason, so it's just a matter of putting what I have done. I've copied and pasted that line 12 there, which is the DF Player Mini. So I've already got it, but if you wanted to download it, it's just a matter of, this is a previous version. I'm not going to do that, but you just install it. It goes off, it installs. All right, so and then that'll add the library to the sketch. So that controls the MP3 player. So it's very important. So that might be the first thing you get if you get an error message saying along the lines of the library doesn't exist. It'll show you down the bottom here in red when you get errors within the sketch. So I'll quickly get out of that and we'll get on to the next thing. So what we'll do, we'll have a quickly look at the components in a little more detail, and I'll zoom in on this schematic that I've made up. So it's probably a little bit easier, I think, to describe to you how this is all hooked up than actually using physically a breadboard with wires and everything hanging everywhere else. So it's actually quite a simple little build. All the connections are on the code, which I will put a link to that below. So at the heart of this little guy is obviously the Arduino Nano. Now this is the version that's got the USB interface. So you can either power off the USB, which feeds you 5 volts to everything on this circuit, or like I do when I install it on the layout, I use another power feed, a separate 5 volt feed that comes in on a separate bus as I've got here. I just think that adds a little more flexibility, because obviously once you start building your Arduino products and your little sketches and your other sort of automation and all that, you sort of need the 5 volt feed underneath the layout like you would your DCC bus. So I'll go through all the pin connections here in detail. Now the next one we'll have a look at is the infrared. So just be mindful, the infrared has 3 pins on it, so a VCC, a ground, and an out. So follow, some of them are not printed correctly, and the reason I found this out is because I've blown a few up. So just be mindful, the out pin sometimes has a positive sign next to it, like mine did, hence why I blew it up. So the out pin is your signal out. Obviously the middle is your ground, and the VCC is your positive input. So those just go to my bus line there, which will get plugged straight into the 5 volt DC. Same with the second one there. So, and then obviously you've got 2 signal inputs to the Arduino. So then we've got the DF player, which holds the MP3 file for the bell. And then we've obviously got the 4 LEDs. Now, just whilst that, we'll start on the LEDs. So the LEDs are what they're calling they're driven by a common cathode. So cathode being the negative side of things, they have a common bus that goes to the negative 5 volts, hence the term common. So they're obviously controlled via the Arduino of the anode side of the LED. So the first one we'll start with will be the DF Mini player. So just to make sure that you get the orientation right, so you got the little divot up the top here that denotes, so on the left hand side you've got pin 1, 2, 3, 4, 5, 6, 7, and 8. But when you come around the other side, it comes around the corner. So the bottom pin here is 9, 10, and then so forth and so on. So we'll just quickly zoom in on that. So the connections that we've got here are, so the first connection we've got is, we'll start at the top. So pin number 1, so that's going to be our VCC, or our positive 5 volt that goes through to the 5 volt line here, or bus. Pin number 2, which goes through a 1000 ohm resistor, goes all the way around to digital pin number 9 on the Arduino. So that's what is physically controlling the negative feed, or the digital in feed, or digital input, I should say, to the mini player here. So then we've got the speaker cables denoted in brown cables. They go to pins 6 and 8. And then we've got, for simplicity, the negative 5-volt feed comes over to pin 10. It can actually go pin 7 here as well, but I just like to keep it well out of the way. So the next ones we'll have a quick look at are and I'll only describe one in detail with all its 3 cables, are the infrared sensors. So the infrared, we'll start with the VCC, which is the positive 5-volt, which comes down to our 5-volt bus. We've got the ground in the middle, which is our negative to the 5-volt bus. And then we've got our control pin, or our digital out pin, that goes to D5, or digital pin output 5, and 6 for the other one. Now, just a little thing on the infrared, they've got this little potentiometer here. So when you first turn this circuit on, you'll need to adjust that up or down depending on the light source that you're using that is above your layout. So normally what I'll do, I'll turn it all the way on so both the LEDs are on. So the LED on the left-hand side is the sensor LED. So that'll only fire up or illuminate when the sensor has detected something. So I just like go all the way up and then just increment it back until it's just off, and then I will put something over there just to test it. So that's how I adjust the potentiometers, and I do that for both. So just another thing on these, what you can also do, and this is what I do, that's a little bit cumbersome when you're getting under the layout, adjusting these when it's connected to this little integrated circuit board here. So what you can actually do, but just be mindful of the polarities, the anode and the cathode of both of them. You can actually add wires between the infrared LED and its receiver, and then have some sort of length to it. So I'll add, 30-40 centimeters of cable to that, and that's more than fine. Just obviously make sure you keep the anode and the cathode correctly to what you're patching it back to the board. So now we're across to the Arduino here quickly. So as I said, you can either power this off a 5-volt USB, which is fine when you're doing bench testing. However, if you don't have a USB feed underneath your layout, you have to find another way of doing it. So these little guys, you can have an external power supply. So I normally go off the V in, so the voltage in, and the ground. So they just come across to my 5-volt Arduino DC line, and that'll power up the whole Arduino. Just be mindful to get these correct. Don't plug it into this 5-volt here, because if you do that, I'll guarantee you'll blow your Arduino up. So now we're across to all the cabling and all that for the LEDs. So this sketch is obviously designed to use LED, not incandescent globes. So just be mindful of that. So I'll leave it up to you what resistor you use. I'll use anything from 600-700K right out to 1,000 ohms. I'll leave that up to you depending on what brightness and intensity you would like. So as described before, this is a common cathode LED. So what that means is the bus comes through, and I do apologize, there should actually be a line from this one here. So there should be that one coming across, so apologies for that. Just like these, to pick up the negative 5 volts. So I use the resistor on the negative or the positive side, or the anode side. That's just what I do. Not saying that's the correct way of doing it. It just seems to work for me. So we control each LED with an output of the Arduino. So the sketch dictates which pins these need to be controlled by. So the sketch knows what and how it's flashing. So we'll start with the very bottom LED, which goes to digital pin 13. The next one up goes 12, 11, and 10. So what that actually will do when they flash off, what they do, so they're grouped together. So 13 and 11 are grouped together, and 10 and 12 are grouped together. So what they'll actually do, they'll alternate their flashing as they would on a wigwag or crossing gate, depending on what part of the world you're in. On the example I'm showing you, I've only got 2 LEDs because it's just the German prototype that I've got, but you can add more LEDs if you wish. So that's pretty well the connections to the Arduino, infrared, and also the little DF Mini. Okay, so now we've got the whole circuit together. Obviously there's a lot of wires going everywhere. Obviously I have explained what they all are. So we've got the 2 sensors here, so it doesn't matter which way the train comes in. So it can either come, so you imagine the sensors are underneath the track, so it can either come in from the left side of screen or the right side. So I'll just put a little piece of foam over one of the sensors, and you can see down the bottom here the lights start toggling. So obviously they're the wrong colour, they should be red. However, that's just a little test panel that I've set up for a whole lot of LEDs with resistors on them. So depending on what LED you use, depending on what resistor value you're going to need. So obviously as a train transverses through the track, it'll go over the other sensor and it should switch the light off and also the sound. For some reason the little light here is not working, but obviously you can hear the sound. So I'll just show you it coming through the other way. So coming from the right of screen, the wigwags go on, the sound goes on, train goes through, the track goes over the other sensor and turns off. So that's the end of this video. So just to recap, obviously what we've gone through today, I've taught you how to flash the Arduino with the sketch, set up the MP3 file. That's obviously quite important that you use the correct format so the Arduino looks for the correct audio file. I've showed you the connections, how to set up to the lights, to the MP3 player, to the speaker and the Arduino, and the way I use the power supply, and also how I connected up the sequence with the LEDs. So if there's any questions you've got regarding the connection or any part of this build, please reach out and email me and I'll endeavor to help you out. It's a fun little build. It's actually quite an easy build. I just thought using the circuit diagram was a little clearer than showing you in real time with the circuit board with wires and effectively going everywhere. So one thing probably I didn't cover is the spacing of the IRs. So that's them there. They need to be reasonably close together. It just won't work. So there's the other one at the far end. So as I said, I probably need to move that right up there. Purely I had it there just so for the video, because obviously the train was already into the crossing before the light started going off. So as I said, end of the video. So thanks for watching and I'll see you next time. Please ask questions, reach out. It's all great community here we've got here, the model railroad techniques. So thanks for watching. See you next time. Make sure you subscribe. Click that little bell icon to be notified of upcoming videos. Support us on Patreon. Like us on Facebook and Instagram at Model Railroad Techniques.